Hello everyone. I hope you're doing well. My name is Sayam and welcome back to the channel, right? Today we're gonna solve the second problem of today's contest. And this actually took me a lot of time. I don't know why. I just tried to figure out some ways, but lead code gave me dhoka. But koi baat nahi. We'll try to see. It's not very hard problem. I just not read the problem. I didn't read the problem very carefully. You have to read it. Let me just read it for you so you don't make mistakes and waste your time and submit wrong answers. So you're given an integer n. I would rate this problem, by the way, it's a medium problem itself. It's a very good medium problem. Not easy. It's actually not a 4 pointer, it's a 4.5 pointer problem. Okay. Return the largest prime number. See, I just missed that also. The largest prime is also a thing. Largest prime. Okay. Largest prime you have to return. Less than or equal to n. That can be expressed as a sum or more consecutive prime from 2. I just missed that. I thought consecutive primes, not starting from 2. So that also you have to think about. Okay, starting from 2. That makes the problem actually very simple. I thought a very good solution, but okay. They say 2 only, so that makes the problem very simple. No such a number exists, return 0. Prime number is a natural number, we already know. Prime to pata hi hoga, we are they are defining prime also. So yeah, that we know. Right. Okay. Firstly, let's try to go to the constraint. Constraints is n. N is 5 into 10 power 4. Okay. Cool. 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 We have to find a prime can be expressed as sum of primes such that it starts from number 2. Okay. Okay. That is perfectly fine. Cool. So how we can think about this? ठीक है. सबसे पहले तो ये क्वेश्चन पढ़ के ही हमको प्राइम्स निकालने आने चाहिए. ओके. प्राइम्स कैसे निकालते सही है? Do you know how to calculate primes? Uh, One method is root n method. Will that work? Uh, can, but you should not go through that because that is not a very good way. You can do that. You can what you can do. You can go for like till n only. You have to find all the primes, right? Because beyond that, it is not possible because you have to find a number which is less than n and sum of primes also, right? So all the primes will be less than n only. So what you can go for every n, you can in square root of n way. What you can go, you can check it out, okay, whether it is a prime or not. So your complexity will be n root n types, and you can just form a primes array. That is our first intuition that you need all the primes, all the primes. That is the basic requirement. I think this is very intuitive to think. All the primes till n we need. We'll see how we'll use that. But till n we need that. Now, first way method I already told you. This is a brute force way. Brute way. Other way, I think most of the people know. If you don't know, then I can tell you. This is a sieve method. Sieve method, an optimized method. You can say that is an optimized method. So instead of going n root n, we can go n log n types. N log of log n, by the way, but something like n log of log n. Okay, let me just write it clearly. But in general, you can say log of log n is also log n itself. So you can say log n itself. Okay, so n log of log n hota hai, but fine, we can go with n log n also, right? Optimized way. How we can do that? This is a very simple idea. What are you gonna do? You don't need to remember it. Sometimes it's very intuitive also. So you have to run a for loop from I equals to 2 and I less than equals to, let's say, till n you have to find all the primes and I plus plus. And then what you're gonna do? You're gonna start a loop from j equals to 2 into I and j less than equals to n, and you're gonna do a j plus equals to I. Okay. This is the time complexity of the solution. And if you try to like mathematically form it, this will turn out to be n log n. Now, how does that work? See, our idea is if I is a prime, let's say I is a prime, तो इसके जो भाई हैं 2 into I, 3 into I, till n, all the numbers which are less than n, multiples of I, क्या वो prime होंगे क्या? नहीं होंगे. Absolutely no, they are not prime. They are not prime. That is our first intuition. Okay, they are not prime. So what we'll do, we'll maintain a primes vector. What you can do, you can maintain a primes vector and you can just say, okay, these set them to false, that they are not prime. Initially, what we'll do? Initially, all are primes. all cows are dogs, something like a problem, right? Similarly, here also all are primes. Let us assume. And then later on, we'll nullify, oh, these are not primes. By mistakenly, we have did them primes. Right. So we'll make them non-prime. And we will see, okay. And then this loop also will run only when I is prime. And if I is not prime, we won't do anything. So here we'll check if already we set to prime, if prime of I is equals to 0, that means we already set to uh, it is not prime. So how इसके भाई वाले तो already अपन set कर ही चुके होंगे, right? We don't require that. So we can continue directly from here. Why we have to do it? Let me just explain you. Let's say I equals to 2 here. Then to we have to set 4, 8, 6 till all to non-prime set to 0, right? If you go from 4, because here we are doing what? I plus plus, every number we are iterating. So if I got I equals to 4, 8, 12, already we have set to 0. Why do you need to go and iterate on this, right? That is not at all required. So that is the idea. If it is already set to 0, that means we don't need to go through this loop. Otherwise, we have to go 2 into I till I plus all the multiples I will make them all 0. So that is the idea of making this primes array. Now what you can do, what you can do, it's very simple. That you make another vector. Yeah, it requires two vector formation, I know that, but the time complexity is less here. It is an optimal version. So yeah, it will help you if their numbers are very large. So yeah, that will help you. So vector of int and p, and what you can do, vector int and p, and then you can just find, oh, whatever for primes of I equals to 1. If this is true, that means what? You will push into your prime. P dot push this I. Oh, this is a valid prime. Now you got the primes until n. I hope you got it right. Now you have to think about, you have to find a number which is a prime and which is the sum of the elements. So how you can do that? Uh, this is a not also not very difficult. You have to start from, and you have to continuously count, like means take a prefix sum, right? Is nothing but just take a prefix sum. Because why the prefix sum logic works here? Because you have to start from 2, by the way. Also, it should be consecutive. It should be consecutive. So we already have a primes vector, which will tell us whether a number is prime or not, first of all, right? Whether a number of is a prime or not. And the second thing, p vector, this will help you to calculate all the primes. Like you know the primes, will iterate in this primes p vector, and then what you will do, will pick up prefix. And since we are iterating the primes vector, all are primes, all brothers and sisters, something like that, right? Prefix plus equals to, let's say I, and you are iterating in p vector, in I in p vector. Okay. Then since you started from 2, because 2 is the first prime, right? So our first condition is met, it should be start from 2. Now we have to, it's also consecutive because taking a prefix, it is always consecutive. And we have to check whether this prefix becomes a prime or not. If prime of prefix, that means this is a valid candidate. Then what will do, we maximize this. Maxi equals to max of maxi, comma, what you can say prefix. And this is a simple idea. And then obviously you have to check it out that if prefix greater than n, you just break it off. You just break it off. That is the idea. So what is our initial intuition? See, in this approach, if you follow n root n approach, you need to form another array, by the way, map or something, which will tell you whether a number is prime or not. You have to store somewhere, because in that way you just know only primes, but you also need to know whether a number is a prime or not. So you need this array primes vector. So you should follow this sieve approach. You can go with this square root n approach also, that to calculate primes. By the way, you have to use another map for that, right? Then we firstly calculated all the primes. Then what was our intuition? That okay, they already mentioned start from 2. So okay, this is somewhere going into the prefix direction. And since they try to make all should be prime, so what we do, instead of iterating in the original n array, let's try to iterate in the primes array itself, right? We iterate in the primes array and we just sum up continuously till prefix. And when At a time, we got a prefix as a prime, which we can easily tell with this primes array, which will help us to calculate, oh, let's try to update our maximum. And we just update our maximum, right? And then we finally will return our max. I hope you get it. It's very simple. And I don't need to show you an example because it's not very difficult. Let's try to directly jump off to the code, which will help you understand it better. Cool. So what we'll do, firstly, let's try to understand the C wala logic. So C wala logic कैसे work करता है? So you iterate from I equals to 2 to I equals to n, and already if it is, we mark this flag as false, you can say 0 1, or you can say true false also, we'll continue. Otherwise we know that I is a prime here, I is a prime here, we'll make all his bhai and sisters make non-prime, so primes of j equals to 0. And this is, I think, intuitive, you can remember in this fashion. I always remember in this fashion. Remember that, don't do j plus plus, j plus equals to I, multiples of I, right? Then what we do, we just find all the primes. I already find the primes, and I make this p vector which will tell me only primes. Here it contains all till n, it's n size array. Here only primes. Now I will do, I'll iterate in this primes array, and then what I will do, I will go, oh, sum plus equals to pi, just the prefix. But if sum is greater than n, anyway this is not useful for me, break it off. Otherwise, if it is a prime, which we can easily tell with our primes array, which we calculated using Sieve, you can do that and you can just maximize the sum and then you just return this maximum. Right? So I hope you understood the entire solution, the entire thought process. And yeah, if you are new to the channel, make sure to subscribe to the channel, like the video. We'll see you in the next video then. Till then, keep learning. Goodbye.